Alright, in this tutorial I'm going to talk about how to use the acquisition tab to acquire data using the optical box that was included on the GVA website. The first step is to select that experimental directory where the data is going to be stored. And then in the acquisition tab, this is assuming that the camera has been connected, the Arduino is connected, uploaded with the software, as was detailed in the written tutorial online on how to build the optical box. Once all those things have been done, you also have to install Digicam controller software, and it has to be running. So here we can see this button LV is live. That means that it's connected to the camera and is seeing the pipette tips that are currently in the field of view. Importantly, transfer to save to PC only so that the memory on the camera doesn't get overwhelmed by all the images. And if the software detects the camera and the Arduino, there will be no error message here, and you'll have access to all the buttons. If it can't find them, it will pop up a red refresh button here that prompts you to open Digicam controller, turn on the camera, or reconnect the Arduino. So the top here are the activities with the camera stage, so you can manually control the stage, which I'll show briefly, calibrate the step size, home the motor to the default position, and then acquire images depending on how many pipette tips you set in the imaging parameters. For the configuration, this is the port that the Arduino is connected to, which can be figured out from the Arduino IDE software. It will tell you what port the software was uploaded through. The motor step size and distance to the first tip are going to be calibrated, and then these are camera settings. So you can increase the shutter speed or decrease the shutter speed if you want more light. F number is deals with the focal depth, and the ISO is basically the gain. If you change these parameters, you can store as default, and similarly to the imaging parameters in the shipped application comes with acquisition default parameters in a CSV file, which when altered here will now load in every time the software is opened. And then finally is the option to try and segment the pipette tips while imaging and apply colony segmentation models. These options will be discussed when we talk about the segmenter tab. Alright, so just to show what it looks like when we want to manually move the motor stage, if I click this button, a pop-up window will indicate that it is now the button on the motor box is enabled. The button on the motor box does not work unless controlled by the software. So now that it is enabled, I can press the button to move the motor. I can change directions. If I go to the end and I hit the limit switch, it won't let me slam the stage against the very far end and will only allow me to move back. Once I'm done moving it, I'll press OK, and now that button no longer will work. It does nothing. The Calibrate button allows us to figure out what is our motor step size and the distance to the first tip. So I click the Calibrate button. It's going to pop up a window that says use the buttons and switches to manually position the stage and center the first 3 pipette tips in the row, and then press OK. So I've already done this, but basically using the motor switch, I'm going to move the tips so that my first 3 pipette tips fill the image, about right there. And click OK. And it's going to re-enable the button so that I can move to the last 3 pipette tips in the row. So It's the end of the box. Too far. Right there. So now I've covered both ends of the pipette tips. I'm going to click OK. You see this manually auto-populates what the step size of the motor is, as well as the distance to the first tip. So now when I click Store as Default, this is stored in that table that came with the experimental directory. So it's the distance to the first image and the distance per step right there. And now whenever you hit home motor, it will go to the limit switch and then go back to that exact same position. So that you're looking at the first 3 pipette tips. So for this particular design, the well A1, pipette tip A1, is on the top of the box, looking from the front, and then works its way down. So this is A1, A2, A3, A4, A5, A6, so on down the line. And so the imaging box moves this way to take pictures in that order. So then when I want to acquire, I'm going to click Acquire, and it's going to take 1 picture and then move to the next 3, 1 picture, and so on. And those images are now stored in this tutorial folder. And the name of the folder is this Canon camera. So these are the pipette tips I'm actually taking pictures of. These don't have any colonies in them, just examples. And I also wrote that experimental configuration file. Importantly, it does not allow you to change certain parameters after you've begun imaging a file, and that's because these are parameters that are required for the segmentation to work. So in order to use those parameters again, you have to select a new experimental directory, and those parameters, such as number of pipette tips per row, are re-enabled. So for a single experiment, you must have the same number of pipette tips per row for the whole box, even if they're just empty pipette tips in there. This also includes a row counter that tells you how many rows you've already counted. So I'm going to acquire again a new round of pipette tips. The row counter has increased to 2 now. And then in a subsequent video, I'll be showing how to use the segmenter tab.